So we're going to look at Chapter 7 and do a quick overview. We're talking about area and volume is the main thing, and work. So if we start with area, so we're looking at the area between some curves. So say I have y equals x squared plus 2x and what's a g of x? I don't know why I put y. Let's make that f of x equals x plus 2. So I want to find the area between these two curves. Now we know that antiderivatives give us area between the graph and our x-axis. So first thing I'm going to do, sorry that's bugging me, is graph these two functions. So let's graph them. I know this one's a line, so I've got a y-intercept of 2. Got a slope of 1, so I'll go up 1 over 1. Down 1 over 1, so I'm going to cross here. So I have this line. Now my other one, I've got this. I'm going to factor that. So say I've got x, it's going to be x plus 2. So it's going to cross my x-axis at 0 and negative 2. So it's going to look like this. If I plug in a 1, let's say it's going to give me 3. If I plug in a 1 here, that's going to give me 3. Perfect. So that's where they meet. Right here, 1, 3. Okay, so we want to find out where these two graphs intersect with each other. If you want to plug them into your graphing calculator and look for the intersections, that's fine too. So we want to find this area. Okay, so what we're going to do is take the top function and subtract the bottom function. So we're going to take our antiderivative from our endpoint, so negative 2 to 1. And our top function here is this one. So that's our x plus 2. And we're going to subtract our bottom function. Okay, so now we're just going to take the antiderivative. So let's simplify that a little bit. So I've got negative 2 to 1. Got x plus 2 minus x squared minus 2x. So let's see, it's negative x squared minus x plus 2. So now let's take the antiderivative. So it's going to give me negative x 3 over 3 minus x squared over 2 plus 2x from negative 2 to 1. Okay, so now all I have to do is plug in my points, and that'll give me my area. So I've got negative 1/3 minus 1/2 plus 2. And I'm going to subtract. If I plug in a negative 2, it's going to give me negative 8 times a negative is positive 8. That's 4 negative. It's negative 2 minus 4. And then we can just simplify that. So let's see. That would give me negative 9/3, so it's negative 3. And give me 6, negative 6 is 8. Right? So should be my negative. So it's negative 6 plus positive 6, so plus 2, it's 8, and then minus 1/2. So it's 5 minus 1/2, so it's 4.5. Okay, I couldn't think to add there for a second. So that would be the area in that curve, would be 4.5 units or whatever the, or units squared, if you're looking at feet or inches or whatever. Okay, so let's talk about volume. So volume's a little different. So we're still going to be using, so if we think about volume, so say I have a curve, and I'm going to take this area and rotate it around my x-axis. Okay, so I take this area, it's going to make it almost a ball shape, like an ellipse. An ellipse. I can't think for this morning. So it's going to be almost a ball shape. So what we're going to actually look at is area. So say I take the area of this little piece, and if I just took that around, that's going to make a circle. And so if I take all these little circles and add them up, we're going to get volume. So my volume is, if I add up all my circles from my endpoints, so I think area is pi r squared. So we're going to use that. So I'm going to have pi, whatever my radius is, squared. So dr. Well, it's really dx because r would be in terms of x. Okay, so let's look at that. So it kind of looks a little confusing, but it's really not too bad. So say I have this function, and we're going to bound it between 0 and 2. So let's graph it. So I'm going to have 0, 0, 1, at 2, at 2, up here at 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm way up here. So say I've got this function. So I'm looking at the area between this curve, x equal to 2, and 0. So I'm looking at this, and it tells me I'm going to spin this around my x-axis. Okay, so I'm going to take this and spin it around the x-axis. So it's almost going to, so you've got this kind of curve here. So it almost looks like the end of a trumpet, because it's going to mimic that down here and fill it in. So it's going to kind of fill in this space. So it's like a tent or like a trumpet if you'd filled it in or something like that. Okay, so we're using this formula. So my radius is my height here at any point. So it would be 2x. So I've got pi. My radius is 2x squared, and we're going to square it, dx. And my endpoints, I'm going to start here at 0, and I'm going to go all the way to 2. Now all I have to do is take the antiderivative. So I've got pi 0 to 2, that's 4x squared dx. So let's see, it's 4, it's going to be x cubed over 3, it's from 0 to 2. So we'll plug that in, so I've got 4, that's 32 over 3 minus 0. So that would be my answer, 32 pi over 3. Oh, and I got out of the way we can see it. Okay, so all we're doing is plug this in. It's going to give me 8. 8 times 4 is 32, divided by 3. Plug in 0, it's going to give you 0. And so that's going to give me my area. Now what if I took this same thing, oh, no, let's look at a different one. So say I have two different functions, and I want to bound them that way. So I say I've got y equals x squared, and y equals 4x minus x squared. Okay, so let's graph these. Let's see. Let's graph this one first. So if I factored out an x, I'd have 4 minus x. So I've got x-intercept here and here. It's going down. So let's see, if I plug in a 2, that should be my midpoint. It's going to give me 4. 2, 3, 4. So I'm going to put here. Okay, so I've got this graph here. So let's graph this one. So I've got 0. If I plug in 2, I've got a 4 again. It's 1. So it's going to look like this. So I'm looking at this area right here. Okay, so we're going to take this and let's spin it around the x-axis again. So I'm going to take that and spin it around my x-axis. Sorry, I've got a hole there. So it's going to be almost, it's kind of weird looking. It's kind of like this banana shape, and it's going to spin this way. So it's almost like a bowl that's kind of curved in, or like a flower or something like that. Okay, so we're doing the same thing, except we're going to find the full volume, and then we're going to subtract out the volume of the middle. Okay, so I'm going to take, it's called our washer method. So I'm going to take the outside function, so that's this one, and we're going to square it, and we're going to find the volume on the inside. Square it, and that's going to give us our volume. Okay, so go through the same process. So let's see, that's going to be x to the 4th. Let's see, that's going to give me 16x squared negative 8x cubed plus x to the 4th. Because x to the 4th would cancel. So it's going to give me negative 16x squared plus 8x cubed. And then we can just solve that. So take the antiderivative. So we don't want to forget our pi. So it's 16x over 3. 16x cubed over 3 plus 8x to the 4th over 4. Oh, we didn't put our endpoints. So our endpoints here were from 0. Let's see, where do they meet? At 2. I forgot those. So we're going from 0 to 2 again. So if I plug in a 2, I've got 16. That's going to be 8 over 3. That's going to be a 2 times 16. And then we plug in 0 to both of those. It's just going to give me 0. And so it's 32. So I figured this out a minute ago. It was 64 over 15 pi. Okay. So, but what if I took this same function and, oh, nope, it was not. I'm looking at the wrong problem when I wrote that down. It's actually 32 pi over 3. Okay, so that's what happens when I make notes and then try to do it. Okay, what if I took the same function and I want to spin it or rotate it around y equal to 6? Okay, so if I come up here, this is for, let's try to draw it again so you can see. Okay, so 1, 2, 3, 4, 5, 6. So I've got this line up here. So I've got this one, and I've got this one. Okay, and we're going to spin it around this line. Okay, so now my radius here, this is my outside radius, and this is my inside radius. So if I look at it, I'm going to do the same thing. So I've got pi. Now my larger radius here is going to be 6 minus, we said that was 4x minus x squared. And then my inside one is 6 minus, nope, I flipped them. This is my x squared. So 6 minus x squared, and this is my 4. So it's going to be 6 minus, what did we say that other one was? 4x minus x squared. Okay. So we've got to do a little bit of algebra and simplify all this first. So let's simplify all of that. And I'm going to cheat a little bit and jump over. So if I multiply all that out, I end up with, and let me find it. So we're going from 0 to 2 again. 48x minus 40x squared plus 8x cubed. Okay. Try to save a little bit of time. Sorry, I didn't mean to bump that. So now we take the antiderivative. So I've got 48x squared over 2 minus 40x cubed over 3 plus 8x to the 4th over 4. Plug in 0 to 2. And we end up with 64 pi over 3. Okay? Now, let's do the same problem, but let's spin it around y. Well, or close. Okay, so say I want to spin it this way. So I've got y equals x squared, y equals 4x. And I want to spin it around the line x equal to 4. Okay, now if we're looking at this, let's draw it again. I've got this one, so it's x squared. I've got this one. So I've got this graph, and I'll spin it around this line. Okay, so we're kind of spinning it this way. It's almost going to be like a donut shape. But if I'm looking at my radius is this way. It would be in terms of y. So I have got two options. I need to either solve for y or solve for x on both of these, and I'm going to end up with square roots. This one's going to be a mess to try to solve and get it in terms of y. So we don't want to do that. We have another method that we call the shell method, in which we find our distance here and our distance there. And we're going to multiply those. So our shell method, in this one we've got 2 pi, and we'll call p of x and h of x. Okay? So p of x is my distance here. Okay? So So my distance here, so this is 4, and I'm going to subtract x. So 4 minus x would give me this distance here. So my p of x would be 4 minus x. My height is here. Okay, so my height is the distance between those two. So we've got our bigger one, which would be 4x minus x squared, minus our smaller one, which would be x squared. So end up with 4x squared minus 2x. 4x minus 2x squared.